Okay. Let's see, and share screen. Okay, so you may have to work with something like this. So, you remember in grade 10, you always had that section on transformations. You're given a parabola, and then you're asked to stretch it, or compress it, and then shift it, or translate it up, down, left, right. You remember that, right? And depending on how picky your teacher was, you were asked to draw every single intermediate step. Right? You start with the parent function, x squared, and then you draw the stretched one, and then you draw the reflected one, and then you draw the one that shifted, and then you draw the one that moves up and down. Is that right? You have to draw the middle ones, middle steps, correct? You remember that? So every single time, and if your teacher was especially picky, every single time you drew the intermediate step, you might have to have written the equation of that middle step, where you only transform one piece at a time. That's a lot of work, okay? And not in terms of transformation, but also in the future, you might have a whole bunch of different graphs trying to overlay on top of each other because you're trying to compare different relationships, functions. So let's pretend we have, the x squared equation. We have a parabola here. We have something, a straight line here. We have an inverse. You don't know that. And we have a trigonometric function. You don't know that just yet. But long story short, there's a whole bunch of different functions, and each one has to be labeled accordingly if you want to know what the functions are. I don't have time to write all that. So instead of writing all of this, we can give it another symbol or a letter or something. If there's a number that we don't know, the variable that we typically learned to use was an unknown number. What letter do we use? X. If X is taken, we can also use Y. If Y is taken, we can use Z, A, B, C, whatever the case may be. The same thing applies for functions. Since we're talking about functions, what is the appropriate letter we could use to represent a function? Okay, but what if F is taken? What's the next letter? U? Are you swearing at people? What's a U? What do you mean U? What's after F? Not U, but G. You can use G, you can use H, you can use I, you can use a whole bunch of different letters. The letter itself doesn't really matter, but typically, we use the letter F to begin. Okay? So, moving down on this sheet, instead of writing all of this, y is equal to some kind of function, we're going to replace the letter y, because y is equal to all of this, right? Instead of the letter y, we're going to write it as a function is equal to this. You see the difference? Instead of saying y is equal to this equation, I'm going to say the function is going to be this equation. And why is it so useful? You'll see a little later why instead of the letter y, we use f of x because the symbol f of x communicates so much. You don't know that just yet, but we'll see. Okay? So here's an example. I have two different equations. Okay. Two different equations. Let's call this blue. We will call the other one red. Okay. The red one is going to be g of x, and the blue one is f of x. Here's why it's so useful. Do you remember those questions where it's like, given, do you have to write this? Given y is equal to x squared plus 2x minus 1, what is y when x equals 2? Do you remember those questions in grade 10? All of this, you know what I can say instead? I can write it all that just in this. Take a look at what I did. I wrote f, which represents what function? The x squared plus 2x minus 1. I wrote 2 instead of the x, which means instead of x, please replace it with 2. F of 2 means using this function, what's the y value when x equals 2? Isn't that really, really short? Super short and sweet, right? So the letter that comes, this is not f multiplied by 2. That's not what the symbol is. This symbol represents I have a function, and I want to put 2 as the x value. Okay, so it's right here. Let me put the little thing. Blue means I am using the function x squared plus 2x minus 1. Right? And then the 2 means the x value is a 2. What is it equal to? That's what it means. And I'll put a little asterisk here saying f of 2 is not equal to f multiplied by the value of 2. That's not what it means, okay? F of 2 means I'm dealing with the function f, and the x value is a 2. That's what it means. So let's solve it. Right underneath, we are going to solve for f of 2. Okay. There's so many different ways we can say it, but typically we will say something like f of 2 or f when x equals 2 or whatever. F of x when x is 2. F of 2 in this case, so instead of y, we can actually write f of 2, but you know what? Let's put it this way. When we substitute the value of x as 2, this becomes 2 squared. This becomes 2 times 2. That's a subtraction of 1. So that becomes 4 plus 4 minus 1. The answer is 7. What does this mean? It means when x equals 2, y is 7. But an easier way to say it is f of 2 is equal to 7. And this communicates all of that. Okay. F of 2 equals 7 tells me for that specific parabola, when x equals 2, y is 7. Super short, super sweet. That's it. This is function notation, function symbolism, function symbols and system. Okay? Any questions? So that's the entire lesson. We just got to make sure we know how to use it, you know, with our hands behind our back and eyes closed. Any questions about function notation? No? Aiden, we good? You're good? All right. I'm going to clear. I'm going to move into the next part of the page, and let's practice it. Okay? Very quickly. F of x is given as this parabola, this quadratic formula, or equation, sorry. Okay. What is f of x when x equals a 0? So f of 0 is equal to, right? It'll be 0 squared plus 5 times 0 minus 24 is equal to negative 24. And again, being lazy, if you are able to do all of this in your head mentally just to save yourself some time, perfect. Okay. F of 1. Who's next on my list? Alex. What does that mean? F of 1. X is 1, so 1 squared plus 5 times 1 minus 24. Yes, because the function symbol was an f, it's always referring to what I defined as f. It's sort of like, if you're into coding, it's sort of like coding, right? You have defined f to be this, so every time I refer to letter f, I am going back and using this. If I define this as g, and then I wrote f of something, they are not the same equation, so I can't do anything. It has to match. Yes?
So kind of like in a simple way, all is equations with whatever that is?
Whatever is in the bracket is what your x value is. Because by default, it's always the function and what number we're going to put in it. It's always that simple. Okay? So it's weird. The textbook calls this like, think of it as like an F machine. And I feel like that's really inappropriate. So I like my explanation a little better. Okay, so we have 1, we have 5, minus 24. The answer to this would be negative 18. Yeah, that's it. So f of 1 equals 18. Quick thing, what does that actually mean on a graph? It means when x equals 1, my y value is 18. You get it? How it sort of all comes together. So in this one, if x happens to be a 0, its ordered pair is negative 24. That's what this means. F of 3? Who's with me? Kennedy, are you with me? Right on. I like how you're doing the square and stuff in your head just to save yourself a line. Yes. So you could just say f of 3. Even in brackets is annoying. It's redundant. You don't have to do that. So you got 3, 0 is my point. You don't have to write this, but I just want to connect it with the graph. All right? Can we do 2 and 3 on your own? If you have any questions you could ask, I'll give you about 5 minutes. I don't think you need more than that, but just get into the habit. And then I'm going to jump straight into number 5 because it looks a little more interesting. Please note the answer key is already online. So. Yes. Question? Oh, someone? Am I crazy? Oh, I swear. Class is going outside. Okay, let's try this. Where were we? I mean a 0. We are at Kennedy. Kennedy, what's up with you? And just start moving along. Did you get to the first couple of questions?
Number 2?
Yeah.
Yeah, I got f of 0 equals
Negative 4, correct. Hazel?
negative 1.
It is negative 1. Good. Okay, f of 1. Aiden? Hmm? Oh, pardon me? Close. So we got 3, 1 squared minus 4. That becomes 3 minus 4 will be, just like before, it will be a negative 1. Just careful with that. And lastly, you might have needed a calculator for this one. Ivan's not here. Marin? Correct. 0.25, 0.75, negative 3.25. You're right. Good. Next. So this time, as opposed to F, I use the letter D. Okay, demand. So D of 2 is equal to, who's gone? Evan. Sydney? 89. I don't know actually. 2 squared. 2 times 20 is 40. Oh, negative 40. 125. 85, 89. Right? Okay, good. D of 5. Jordan? Okay, that's fine. How about I'll just work on it together then. We've got 5 squared is 25. 5 times negative 20, negative 100. Plus 125, 50. Please correct me. Do it yourself, don't just copy. I could be wrong. And then 8. 8 squared, 64. 8 times negative 20, 160. 125. becomes negative 35, 64, 25, 29? I think so. Please double check. The answer key is correct, but I'm not doing my calculator right now. So 10 squared, 20 times 10, so negative 200 plus 125, negative 25. All right. Want to double check? I'll give you a second. Might want to check my math to make sure I'm not doing it wrong. If you have gotten all of it and you're feeling pretty good, take a look at number 5. See what you can make of it before I explain. I'm going to be there in a minute. Number 4 is basically the same idea, so number 5 will be interesting. All right, clearing. And 1. All right. Number 5. Okay, just as before, now that we know how to do function notation, we can use that to our advantage and create relatively complex equations or problems with minimal writing. Like for example, okay, so let's pretend, well, in this question, I have f of x labeled as x minus 3, and g of x is labeled as x squared minus 2. Bringing our rational expressions back, you know that instead of, let's say I gave you a question of x minus 3 over x squared plus 2, just like that, right? Where the top part is supposed to be the gray and the bottom part is supposed to be the red. You know that instead of writing it this way, I could have just as easily given you the question as, please simplify this rational expression. You see it? You see how that's written? It's exactly the same thing because f of x represents the gray one and g of x represents that one. So you should be able to see that and understand it as, oh, it's just this function divided by that function. Okay? So that same idea, what is f of 0 plus g of 0? Go ahead, James.
Negative 3 plus 2.
Right, so f of 0, if you plug it in, is negative 3. G of 0, if you plug it in, is a 2. So f of 0 plus g of 0 is like saying negative 3 plus 2, which is negative 1. So knowing your function notation sort of opens up a lot of different ways we can ask the same question, but in shorter form. A lot more simpler and compact. How about the next one? Find me the product of f of 1 and g of 2. Where is it? Hey, no, we did Hazel. We did Aiden. Ivan, what do you think? What does this represent? What would you do? You don't have to give me the final answer. What are you going to do? Yes. What with what? Not just the numbers. Let's find f of 1 first, which is? No, you don't need to. You don't need to. Find me f of 1 and find me g of 2. F of 1 being 1 minus 3. Good. And g of 2 is 2 squared plus 2, which is 6. F of 1 times g of 2 is the same thing as, saying negative 2 multiplied with a 6. That's it. All right? So take note of these square brackets multiplied by these brackets. They're separated. So the answer to this question is negative 12. I'm starting to get the hang of this, sort of. This is a bit of a test. I'm going to read this in a purposeful way. Ready? F, what is f of g of 2? What is f of g of 2? I want to know what the answer to the function f function is, but what's the number I'm putting in? I'm putting in g of 2. What would that be? See if you can figure that out. It's not really math, but more just understanding how the symbolism works. What is f of g of 2? Don't mind you being wrong, I just want you to give it a shot. What is f of g of 2 in your opinion? Uh-huh. Yeah, absolutely. So I have f of x, right? Clearly that says f of something. But what do I put in as my value of x? Whatever the value of g of 2 is. You get it? So what is g of 2? Well, 2 squared plus 2 is 6. So essentially what we're doing is putting in 6 into the function of f, which becomes 6 minus 3. The answer to that is 3. Jordan, could you try the next one? I'll give you a second. I'll give you a second. Just work it through. Everyone else, please work it through as well. What do you think?
So, G, like you're doing something else last time.
Yes.
So G, G X and G two. So then you're just doing like exactly what you did last time. G squared plus G equals 6.
Oh, close. But remember, this is now g of f of 2. So I want to find out what g is, right? The function of g is, right? But what are we putting in as my value of x? F of 2. So I have to solve this part first. And then you're putting that number in.
That would be G squared plus 2.
Oh, no. Now that we're doing the f, we're actually referring to this function.
Okay.
So it'd be, yeah. It's okay. 2 minus 3, that's a negative 1. So you're putting in g of f of 2 is the same as saying g of negative 1. And I plug that in. Negative 1 squared is a positive 1. That would be 3. Okay? This is function notation. Yes?
Wait, why is it 3? Why is it equal 3?
Okay, let me work that through. So the x value that I'm putting into the function g is negative 1. So that will be negative 1 squared plus 2. And negative 1 times negative 1 is positive 1 plus 2.
Oh.
That would be 3. Okay? That's essentially it. What I have for you is we have a lot of time, and again, I had planned to just have tutorial office hour, but you have to stay. So if you go to our course and our post here, you will see a whole bunch of Waterloo resources for both domain and range and function versus relation, as well as a section for function notation. So you can go to that and practice, etc. Okay? But since not everyone here will have access to a computer or they don't want to use it, I'm going to assign some textbook work for you just to keep yourself busy a little bit and practice. Please also note that the quiz is up. Some people have already finished it. It's on 1.1, domain and range and functions, 1.2, function notation, and radicals, which is 1.4. All right. Let's go back to our whiteboard. Oh, it's fully cleared. Isn't that convenient? Okay, I would say just for function notation, page 22, we've got numbers, actually just for practice. Not mapping notation, 1, 2, first order pairs, 1 and 2, technology, nope. Well, essentially, yeah, I'll keep you busy. For 1.1, functions, so this is 1.2. 1.1, page 13, numbers 5, and 7. Seven's an interesting one if you don't have the graph. So we'll see what happens. Okay. Domain and range of each. Good. Yeah, we'll just have those 4, and that should honestly keep you busy for a good chunk of the time. And the rest of the time, if you have any questions, especially with the quiz coming up or any assignments that you have on rational expressions, please use that during this time. Okay? Any questions?